Hello everyone, welcome to this class. In this class, we're going to deal with fractions and focus more on word problems that leads to fraction. Let's start with exercise 3B number 12. It states that a woman spent 1/3 of her money at the market. So this is market, and she spent 1/3 of her money, and 1/4 at the chemist. So this is chemist, and she spent what? 1/4, and 1/6 at the electrical shop. So this is electrical, and she spent 1/6 and had 555 naira left. So left is 555 naira. How much money did she have to start with? What they're trying to tell us is how much did she start that she started spending all this money on. First thing you're going to know whenever you're dealing with fraction is that the total of whatever you are being told is 1. So the total money she was spending before is what? 1. So from this one, she was taking out all these things. Are we together? So let's start. So as I said, the total is 1. You can likewise call it 1x or just x. But to avoid confusion, we are just going to start with 1. We already know 1x, that's 1 times the number we are solving for. So let's start. Initially, she has 1, and she spent 1/3. Also spend at the same time 1/4, and also spend at the same time 1/6. Are we together? So when we subtract all these things, we will now know what was left that gave rise to this 555. So we can just call this 1/1 because it's same thing as 1 minus 1/3 minus 1/4 minus 1/6. So what you're going to do, you find the LCM of this whole denominator. The LCM is what? 12. Lowest common multiple is 12. So 12 divided by 1 is 12 times 1 is still 12 minus 12 divided by 3 is 4. 4 times 1, 4 minus 12 divided by 4, 3. 3 times 1, 3. 12 divided by 6, 2. 2 times 1, 2. Remember when we are dealing with fraction, which fraction is bigger from here? Which of the fraction is bigger? Obviously, this one is not a fraction. This one is just is 1, but we can still call it, if you want to call it a fraction, this is the biggest. Well, this one is not a fraction. So let's check 3, 4, and 6. 1/3, 1/4, 1/6. Which one is bigger? Obviously, you see that 4 corresponds to 1/3. So this is the biggest, followed by 1/4, followed by 1/6. Don't forget. So when you subtract this, you have 12 minus 4 minus 3 minus 2. Same thing as 12 minus 9. So you have, that's 3/12, which is the same as 1/4. So what she has left was 1/4, which you can likewise call 1/4x, because x is the value we are looking for, the fraction. If you want, you understand, you can say 1/4x. Then this 1/4 is now equal to 555. 1/4 of x. Remember, this is the remainder after she has finished spending, and we have been told that this remainder is 555. So we are now being told, let's look for the real number that she started spending. So when you forget the 1/4, 1/4 of a certain number, which is x, is 555. So the x is what we are now looking for. So x will now be 555 times 4. So x will now be 2220. Answer. One thing I want to point out here is that when you go to the exercise part of this, where I'm solving this exercise 3B number 12. You notice that what they got there is exercise 3B number 12. They got 2200. This is an error. So in case if you see it in your own textbook, just correct it. So let's go to the next exercise. Okay, this is question 13. This question has to do with some people can finish a piece of work in some certain time. How long? You know those type of question. I'm going to break it down to you how you can solve it easily. It says Ayuba can hoe a yam plot in 5 hours. This is Ayuba. Can hoe it in 5 hours. And Salihu can hoe it in 4 hours. This Salihu can hoe the same piece, the same plot of land that Ayuba did in 5 hours. So that's what I mean by it in 4 hours. This one is about what problem. You need to be very understand everything they're talking about. What fraction of the plot can each of them hoe in 1 hour? So the first task we are being told to do is what both of them can do in 1 hour. What fraction of the plot will they hoe in 1 hour? Okay, I'll say this. How long will it take them to hoe the plot, to hoe the whole plot working together? Abi? Okay, if they work together, I think I missed this part. What fraction can each of them hoe in 1 hour? This is the first task. We call it task 1. This for each of them in 1 hour. And then second task say if they work together, what fraction of the plot will they hoe in 1 hour? So the task 2 is if they work together, both. I'll just write it both. How many can they do in 1 hour? Why? You say how long will it take both of them to do the whole plot working together? And take task 3 is the whole plot. Let me use the word plot here. So let's go to task 1. Ayuba can do this in 1 hour and Salihu can do it in 4 hours. So to solve the first one, let me say task 1. What fraction can each in 1 hour? So this one is very simple. Just know that if Ayuba can do it in 5 hours, Ayuba is 5 hours here. So for what he will do in 1 hour is simply 1 over what he can do in 5 hours. You understand? So Ayuba in 1 hour will simply be 1 over what he can do the whole plot. Then for Salihu, there's some challenges here. For Salihu, can do his own in 4 hours. So Salihu for 1 hour, his 1 hour will be simply, this is 4, simply 1 over 4. Sorry, what fraction of the land? Sorry, this is land, not hour. Can do this fraction of the land. This is for Ayuba, and this is for Salihu. And that's for task 1. We are done with task 1. So when they work together, which is task 2, when they both work together, what fraction of the land can both of them do? Simply add the fraction each of them can do in 1 hour, and that's what will give you the fraction both of them can do in 1 hour when they work together. So the answer is simply 1 over 5 plus 1 over 4. Find the LCM. The LCM is what? 20. 20 divided by 5 is 4. 4 times 1 is still 4. 20 divided by 4 is 5. 5 times 1 is still 5. So from here you can tell that 1 over 4 is bigger than 1 over 5. I'm just mixing the two together because this is what this class is about fraction. So this is what fraction that both of them can do in 1 hour. This is the second task answer. Are we together? So the next thing we are going to check for is the last task, which says if both of them work together, how long will it take them to finish the plot? So task 3. Let me just make this task 1. Where is task 2? This is task 2. Then task 3. So if in 1 hour, this is a fraction of the land they can finish. This one is just simply say that if they work together, it will just take them, you just flip this answer you get here, 20/9 hours to finish the land. If you change this to mixed fraction, is 20 divided by 9 is 2 remainder 2. So you can just say 2 whole number 2/9 hours. This is how to solve this kind of example. I wish we have a lot more of it in this exercise. I will explain it further. This flipping simply means 1 over this over, but if you want a logical explanation to it, simply do that. Let's come to this Salihu's part. If Salihu can do, this is the land, let's say L is the land, and the total time it will take him to do it is 5 hours. And you're being told, okay, how many fraction of the land can he do in 1 hour? This is 1 hour, and this is what you are looking for now, x, right? When you do your cross multiplication, you just have 5x equal to the land, because 1 times L is still L. So you now say x will now be land over 5. That's what is giving you this. I don't want us to go through those long processes. That's why I'm just going. Anywhere you see this kind of math, this is how it is being solved. I'm just doing it because this is a lecture class for us to understand it better. The same thing applies here. You can say, okay, for Salihu, you can say 4 hours is what he needs to do the land. Then 1 hour is what x. By the time you solve it, you're still getting this. The same way I solve for this using cross multiplication. Then now this task will now ask you, how long would it take both of them in hour? That's fraction. We already know that you have to combine the hourly rate of both. Then coming to task 3, if you have been told that, to make sense out of it, you have been told that this fraction of the land is done in 1 hour by both of them, you can just say, okay, in 1 hour, both of them were able to do 9/20 L, right? Now you're being asked, how many hours it take both of them to finish the land? That would be like x to finish the land, right? You now do your cross multiplication. You now have 1 hour times L is equal to 9/20 Lx, right? You now make x the subject of the formula here, and when you do that, x will now become 1 hour times L all over 9/20 L. Normally L will cancel out. When L cancels out and you now solve 1/9/20, which is what I said that we did here, 1/9/20 gave us this. It will give you 20/9. The hour is still there, hours. So this is like the logical way to explain it. But when you have been given, when you go to a lot of, maybe a lot of exercises, you see they solve this kind of thing, they just go straight and just go straight to this point. But instead of boarding you down with this kind of expression, I think we'll follow the way it is being done on a conventional way so you understand it better. Let's go to the next example. So we'll go to number 14. How many pieces of string each 8 whole number 1/2 cm long can be cut from a string 42 whole number 1/2 cm? This is simply a division of fraction. It's like you're given a string like this, and the total of that string is 42 whole number 1/2. You'll be told how many can be cut out from it, how many of this length. So it's simply, the answer is simply 42 whole number 1/2 divided by 8 whole number 1/2. And remember what I told about fraction. It's always good to divide fraction when you convert it, when you take it out of this mixed fraction form. So how do we do that? 2 multiplied by 42 is 4 and 8, 84 plus 1, 95. So this becomes 95 over 2 divided by 2 multiplied by 8, 16 plus 1, 17 is plus 17 over 2. And when you are dividing fraction, you have to change this to multiplication sign. So it becomes 95 over 2 times, this will now inverse itself, 2 over 17. Remember when I said 2 times this is 84 plus 1 is 85. So this is not 90. I think I made a mistake. Sorry for that. So this is 85. So now start the division. 2 divided by 2 is 1. 17 divided by 1. 17 divided by 5. So your answer is 5. The answer is 5. So what it's trying to say is that when you have a string that is this long, you can cut 5 of this out of it. To not have a unit, no cm. You know, when you divide this by this, the cm cancels out each other. All these things are things you're supposed to know. So let's go to the next example. Number 15 is say what is the product of this and that? That's one whole number 7 over 9 and 3 whole number 3 over 4. Simply write it out. One whole number 7 over 9 times 3 whole number 3 over 4. The same thing I said about division, what we are doing in multiplication. Try and do what? Change it to improper fraction first before doing multiplication. 9 times 1 is 9 plus 7 is what? 16. So this is 16 over 9 times 4 times 3 is 12 plus 3 is 15. This is 15 over 4. So now multiply. 4 will cancel each other 1 and here is 4. 3 cancel here will give you 3. 3 cancel here will give you 5. So your answer is 20 over 3, which you can also call, change it to improper mixed fraction. 20 divided by 3 is what? 6 remainder 2, so it will be 6 whole number 2 over 3. So these two are the answer. So you go to the B part. The B part say what must be added to the product of this 1 whole number 7 over 9 and 3 whole number 3 over 4, which is the same thing we have here, to make a total of 8 whole number 1 over 3. Now we don't need to solve this again since we've already solved it in the A part. So this is what we are dealing with. This we are being asked this 8 whole number 1 over 3 plus x. What must be added? I think I missed it. This is not what I was supposed to do. We are being asked this 6 whole number 2 over 3 that we got here plus x. What should be added to this value to give us 8 whole number 1 over 3? Are we together? So if we make x the subject of the formula, we have 8 whole number 1 over 3 and 6 whole number 2 over 3. Remember that when you are adding, for addition and subtraction, you can use mixed fraction to go. All you need to do is solve the whole number separate. So this will be 8 minus 2 minus 6 will give you what? 2. Then you solve this fraction separate. 1 over 3 minus 2 over 3. I think we have a little dicey situation here, but I'll explain it. So the LCM of 1 over 3 and 2 over 3 is what? 3. So then 3 divided by 3, 1 times 1 is still 1, minus 3 divided by 2. 3 divided by 3 again is still 1. 1 times 2 is still what? 2. So from here, you can see that 2 over 3 is bigger than 1 over 3. But now we have a situation here to deal with. Are we together? We cannot subtract 1 from 2 in this form. That's why sometimes it's also always good to solve this in the improper fraction form. Because if we're solving it in proper fraction form, we'll not have to deal with this little situation I will teach you here. So when you have this kind of case, you have to carry 1 from the whole number. And when you pick 1 from the whole number, what are you going to call that one? Let's go there. If I pick 1 here, what will be left now will be 1. So what am I calling it? When you pick 1 from the whole number to add inside the fraction you are subtracting for, call it whatever the denominator is. Whatever the denominator is. So if I pick 1 here, I'll call that 1 3 and add that 3 to 1. So I'll have 4 minus 2 over 3. I think this is a special case. That's why it's good to solve some examples, because when you solve some example, you get used to some. You see some certain situations. So when you now solve, you have one whole number 2/3. This is your answer. So whenever you are solving for subtraction of mixed fraction and you have to carry something and add to the number, in case when you want to subtract, notice that the one you are subtracting, the one that is being subtracted from is smaller. Call whatever you pick, whatever is in the denominator, and add it. For those that want to be sure that we got this correctly, let me change this to mixed fraction. This 8 whole number 1/3. I'll change it to mixed fraction. I will have 3 times 8, 24. 24 plus 1, 5. So I'll have 25/3 minus whatever I got here. So this is what I'm subtracting from, 20/3. So it will give me 5/3. I think I jumped step, but both of them have the same 3, so you just have to subtract whatever is in the numerator. When both of them have the same numerator, just subtract the numerator and you get your answer. So this is what I'm going to get. So if I change it to mixed fraction, it will be 5/3 is one whole number 2/3. See that we are getting the same answer. So try to use this opportunity to learn what we just did here. So let's go to the next example. Let's go to example 17. 3/4 of the girls in SS1 play basketball and 4/7 play volleyball. So we have two games. Let me call volleyball VB and call basketball BB. So 3/4 plays basketball and 4/7 plays volleyball. Every girl play at least one of these games. So whenever you hear this kind of statement, what they're trying to say is that every girl in the class played the game, because there are some cases where you have some did not play. So but when you have hear this question, so just for you to know that there is no case of that, so that when you are solving it, you can use that logic and apply to solving. If 27 girls play both games, how many girls are there in the class? Now remember what I said, whenever you're dealing with fraction, assume that the total is 1. So the total number of girls in this class is 1. You understand? So they're trying to tell us that 4/7x plays volleyball and 3/4x plays basketball. So the total number that play both games, because inside this volleyball some play basketball, and inside this basketball some play volleyball. How do you now know those ones? When you add this number and is above 1, just know that the SS that you are getting is those extra that is inside both of them. So let's add. First we do 4/7 plus 3/4. So what's the LCM in this case? LCM of, this LCM, I'm not going to touch it in this case, elementary maths. I believe we all know it already. That's why I'm jumping this step. The LCM of 4/7, 4 and 7 is 28. So 28 divided by 7 is what? 4. 4 times 4 is 16. Plus 28 divided by 4 is 7. 7 times 3 is 21. Yeah. So I'm going to have 37/28. Are we together? So as you can see, the numerator is bigger than the denominator, meaning that it is already above 1. Right? Let's get the SS. The SS is a prime number, so this fraction is kind of going to remain like this. Or if I change it to mixed fraction, I'm going to have 37 divided by 28. I'll have one whole number 9/28. So this is the SS, 9/28. Are we together? So this 9/28, I hope I'm correct. 37 minus this is 9. Okay, one whole number 1/28. So this SS that is extra to this one is the, if 27 girls play both, is those ones that are making this fraction to be more than 1. So we already know that 9/28x is 27. Therefore x is what? X is the total number in the class. Put it together. So this is a fraction of the total number of students in the class. So now we are trying to look for X, because all this we should look for. How many girls are there in the class? So that's what we are looking for. So X will now be 27 when you change this to the equation, times 28 over 9. So when you put your calculator, normally 9 cancel here is 1, while 9 cancel here is 3. 3 times 28 is 84 girls. Right? This is your answer. Let's go to the next example. Number 18 of exercise 3B. In an election, there were 3 candidates. So we have candidate A, candidate B, and candidate C. 3/7 of the electors voted for the winner. So let's know the total number of the electors we don't know. Let's call them X. So 3/7 X voted for the winner of the 3/7 X voted for the winner. Yes, the runner-up received 5/8 of the remaining votes. Let's not get this thing twisted. Some will think this means 5/8 X. No, it simply means 5/X of, let's say, after you take away this 3/X from this X, what was remaining? 5/8 of that. Let's assume we have 5 voters and the winner got 2. They are trying to tell you that the second, because runner-up means second position, got 5/8 of what is remaining. When you take away 2 from 5, you have 3. So you got 5/8 of what? 3. That's what is remaining. So not direct fraction, but fraction relating to the remainder. So I don't know how to express this here, but if I am to do that, what I'll do is I'll just do 5/8 of what is remaining, because I told you that the total of, whenever you're dealing with fraction, total of everything is 1. So 5/8 of 1 minus this fraction, 3/7. I think this is the best way. So when you take away this fraction from the total number, what is remaining? You find 5/8 of that. I think that's what the best way to go about it. What fraction of the elector voted for the third candidate? Now, I think it is getting more complicated. So when you've taken away this and taken away that, whatever remaining is what the last candidate will get. Understand? Because remember, mind you, what they talk about is voters. They're not talking about the city. If they talk about city, you now ask, oh, what about those that did not vote? Am I assuming everybody vote? Yes, because the question is talking about voters, the actual people that voted for. So that's why we are explicitly making use of all the whole voters. So then the third question say, if the winner, okay, let's solve this first. So the total number of voters, we call the voter X. So 3/7 X voted for the winner. Now we have been told that 5/8 of what was remaining voted for the runner-up. So what was remaining is actually 1 minus 3/7. You can keep on putting X. You can ignore it. So don't think, why is it at the end of that I'm bringing in X? As you're solving this, there is an X attached to it because I call the voters X. So let me remove it so that my solving will be more neat. So 1 minus this will give me 7 minus 3. But when you call LCM is 7, then you can 7 divided by 1. You can assume there is a 1 here. 7 divided by 1 is 1 times 7. The same. This one is still the same. So at the end you get 4/7. So this is the remainder. This is what was remaining after 3/7 has voted for the winner. So this is remaining. So the runner-up now got 5/8 of this thing that was remaining. So the runner-up runner-up, which is the second position, got 5/8 times 4/7. 4 here, 4 here is 2. So you're getting 5/14. So the runner-up got. So now the question now is, what did the third candidate take? Was the question, what fraction of the elector voted for the third candidate? So if the total people that voted for election are 1, and you have been told that the winner got, let's call this 1/1, she's still 1. You have been told that the winner got 3/7, and the second person got 5/14. So you know that the remaining ones are for the third candidate. So this one subtract from what the first person got, subtract what the second person got. Whatever you have is for the third candidate. So let's solve. LCM here is still 14. 1 divided by 14. 14 divided by 1 is 1. 14. 14 times 1 is 14. Minus 14 divided by 7 is 2. 2 times 3 is 6. Minus 14 divided by 14 is 1. 1 times 5 is 5. So what you're getting, this plus this is 1. So you're getting 3/14. From here you can see that 3/7 is bigger than 5/14. Look at it. 3/7 is 6. 5/14 is 5. So this is what the third person got. Let me use the word person. So third person got 3/14 of the fraction of the total vote. So this is the answer for our A. Then for the B, if the winner received 3021 votes more than the runner-up, how many electors voted? So they are trying to say that the difference between, the difference between the winner and the runner-up is 3,021 votes. So you're now being asked, what is now the total? So let's express it at fraction. First, let's find the difference between this and that, because this is the winner. Where is it? 3/7 is the winner. 5/14 is the runner-up. So I've been told that 3/7 x, everything is x. I just don't want to be adding it. 3/7 minus 5/14. When you subtract it, you have LCM is 14. I think we've done this here. This is 6 minus 5, which is 1/14. Now, we are being told that 1/14x, but this is a fraction that expresses the difference between the first position and the second position. We are being told that this fraction is 3,021 votes. So 1/14x is 3,021 votes. How many people voted? So this is a fraction of the voters that is showing 3,041 votes. So to find this actual voter, it will be 3,021 times 14. So when you solve this with your calculator, you will get 42,294 voters. This is your answer. So this is the last example we are going to do for in this class. If you have any question, drop it in the comment section. See you in the next class. Thank you for joining.